Hello everyone, good evening.
Good evening, sir.
Good evening.
Good evening,
sir. Hi, good evening.
Good evening, sir.
Good evening, sir.
Okay, so first of all, uh, you all may have received the announcement regarding week 5 by now on the portal. So week 5 graded assignment have two parts. Part 1 is the normal NAT MCQ type, which you guys used to do. And part 2 is EMQ. Okay, you can also go through the grading pattern. We have changed some grading in that as well. And also we are experimenting this and would like to see your scores and utilize it. So it would be very helpful if you guys agree to allow us to use your data for this. And if you allow us, you will be awarded with 0.5 bonus marks in the practice assignment bonus marks, which is 5 marks for the whole term. So you'll be awarded 0.5 bonus marks if you allow to share your data for this purpose. And your personal information will not be shared with anyone. So yeah. Moving on to this session. Okay, so week 4 solve with us. Can you all please go to joinpd.com and enter the code on the right top of the screen? Your voice is breaking. So go to joinpd.com and enter the code on the right top of the screen, which is EAQMES. And also keep a notebook and pen with yourself. You will be given like 5 to 10 minutes to answer every question. And enter your answer in the joinpd.com only instead of Zoom chat. If you are joining from laptop or desktop, your view will be as shown in the left side of the screen. And if you're joining from mobile, your view will be shown in the right side of the screen. You have to click on the right bottom of your mobile screen to answer the question. Okay, moving on to first question. Okay. First concept is of row relative frequency and column relative frequencies. Right? So to find the row relative frequency, the entries in each row of the table is divided by the total of that respective row. Okay, and similarly for column, each entry of that column is divided by the total of that respective column. By that, we get row relative frequencies and column relative frequencies. If row relative frequencies or column relative frequencies are similar for all rows or columns, then we say that the variables are not associated with each other. Here, the variables we are talking about are categorical variables, both of them. If the row relative frequencies or column relative frequencies are not similar for all rows or columns, then we say that the variables are associated with each other. Any doubt till now?
No, sir. None, sir.
Sir, why first option?
No, sir.
Means if row relative frequencies are similar for all rows, then we say that the two variables are not associated.
With each other, yeah.
Why it is that?
Okay, we will discuss that after from this data, right? Okay, from this data we will discuss.
So one more question.
Yeah.
Sir, if row related frequency is similar and the column relative frequencies are not similar, then we
It won't happen anytime.
okay.
Yeah, if row relative frequencies are similar, then column relative frequency will also must be similar, you can say. It's
Okay.
vice versa.
Okay. Okay.
And yeah, I tried to keep the slides small because that's the last session for week 4 we are having. So we can take doubts after the slides as well.
Sir, when to write proportion and when percentage?
It depends on question. Here the question said that but proportion, so you have to write in
So
proportion.
proportion will be fraction, and when I write percentage, it will be numbers.
Yeah, proportion will also be a number. You have to enter number, but it will range between 0 to 1 only.
Okay, okay, understood. Fraction. Okay, thank you.
Okay. Do you guys need more time in this?
No, sir.
No, sir.
Done, sir.
Okay, someone is answering 100 as well. Okay, so you have to tell what proportion of total students are FAMU, which is referred to as the second year students only. So we know that total number of students here are 300. 100 are freshmen, 100 are senior, and 100 belongs to the second year. The number of students who are in second year are 100. So the proportion of those students is nothing but 100 over 300, which is 0.33. Okay.
If we enter 33, will it wrong?
Yeah, it will be wrong
Percentage?
because here we are asking proportion, not percentage.
Okay, thank you.
So sometimes it is 0.33 or sometimes it is 0.34 as well, right? So would we be awarded for that range as well here?
Yeah, there is always a range for every question. Like if answer is 0.33, so the range will be 0.30 to 0.36. So any answer in between this value will be awarded.
Okay, okay. Sir.
Sir, excuse me, sir.
Yeah.
Actually, I actually used 55 by 300, but why haven't we only used 55 by 300? Why it's total 100?
Because we are talking about students who are in second year, right? So second year students are this whole column, right? Not just this observation.
Okay, okay.
Of this 100 students, 55 owns the credit card and
Hmm.
45 don't. So total
Okay,
number
okay.
of second year students are 100.
Okay.
Okay. Yeah. Moving on, it's the same data, same survey of Washington State University students. And here you have to tell what proportion of total students do not own a credit card.
Done, sir.
Done, sir.
Done, sir.
Done, sir. Done, sir.
Hello. Hello.
Yes.
Yeah, where we have to reply if we have to provide my response.
Go to joinpd.com. Open in a new tab, joinpd.com, and enter the link shown on the right top of the screen.
Can anyone share joinpd.com, please?
Just
In
enter on
chat
the new tab, joinpd.com, the new
Okay,
tab.
okay.
Open it. Yeah.
pd.com.
Share on chat, you can just.
Sir. Sir.
Yes.
Sir, if we have a number like 0.185, sorry, 0.295, so should we write as for exactly 2 decimal accuracy, should we write as 0.29 or 0.30?
0.30.
Okay.
If the third digit is 5 or greater than it, you will have to add 1 to second digit.
Okay.
Okay. 375. Okay, someone is answering 375. We will have to look his data. Okay. Yeah. So what proportion of total students do not own a credit card? Okay, so we know that total number of students are 300, and number of students who do not own a credit card, you just have to add the second row. 58 freshmen don't own a credit card, 45 second year students don't own a credit card, and similarly 19 seniors don't own it. So total number of students who don't own a credit card is just the sum of these three observations, which is 122. So the proportion of students not owning a credit card is 122 over 300, which is 0.41. Okay. Any doubt in this? Yeah.
Sir, I have written a 0.406 value, so it will be correct or wrong?
In exams, it will be considered correct, but try to enter only 0.41 because it's mentioned in the question that 2 decimal places only.
Okay, sir.
Sir, I have written 0.40, so will it be considered incorrect?
No, it will be considered correct. See, what happens is for every question, right? Whenever we ask you to enter data to 2 decimal places. So suppose let's answer is 0.47 or 46 away. So any value in between 0.43 and 0.49 will be considered correct. But in some question, it is possible that only 0.46 will be awarded, not any other range. So if it's mentioned round to 2 decimal places, just try to do it.
Sir, in one of the activity questions, if you give the third decimal, it is showing wrong. So it's always better to stick to the two decimals.
Stick to 2 decimals.
And even in our graded assignment 3, the first question was like round to the nearest whole number. So
yeah, you have to round it.
Yes, sir. Hello.
Yeah.
Yeah, it is if we are using in a physical calculator, it's coming for 0.40.
0.40. No, it won't come 0.40. It will come 0.4066 something.
122 divided by 300. I'm having a calculator with me. It's a physical calculator, not in system or somewhere. And if it is in Excel sheet, it's coming for 1.
Okay, because you have put in the formula, I think.
Okay.
Let me share my screen. Let's see if it's. Let me show you an example of it. Okay, see. Can you see my screen, Excel sheet?
Yes, sir.
Yes.
If you
Yes, sir. Yes, sir.
It's coming out to be this, but I think you may have already rounded out to 2 decimal place. So that's why it's 0.41 showing.
Okay, fine. Maybe in my calculator.
Yeah, and also we will be given this TCS calculator.
Yeah, I can use them. I'm just watching in mobile right now. That is what.
Okay.
Okay, fine. Understood, sir. Thank you.
Yeah, moving on to this. Okay, so next question, it's again the same data. You have to answer what proportion of students who owns a credit card are freshmen. So read the question carefully. Here, the main focus is only on the freshmen, not on the total audience.
Done, sir.
Done, sir.
Sir, if the third value, the third decimal point is equivalent to 5, then we will round it off to the next decimal value, or we'll leave it as it.
Okay, you have to enter answer to 2 decimal places, and you are getting third decimal place as 5, right?
Yes, sir.
Then you have to add 1 to the second place.
Okay, sir.
So,
Excuse me, sir.
Yes.
Sir, I'm Rupan Mandal. Sir, I'm having a doubt in one of the questions of graded assignment 4.
Okay, after these slides, we'll move on to that.
Okay, sir.
Yeah, I have kept the slides small because you're not having 3 sessions this time for week 4. Yeah.
sir, if we have a number like 0.2947 and we should round it off to 2 decimal places, is it 0.3?
No, make it 0.29 only.
So should we check from 4? Like for 2, like we need like the last 3, right? So
Yeah, for second decimal, we keep count till 3 decimal place only.
okay, thank you.
What would be the syllabus for quiz 3? Sorry, quiz 1.
Week 1 to 4.
Okay, thank you, sir.
Done, sir. Done, sir.
Yeah.
Sir, in week 5, basic concept are only 2 videos.
Yeah.
Hmm.
Actually, we used to have all this content in week 6. Earlier, we used to give a refresher week, like no content week, just to refresh.
Okay.
So we have split it into 2 weeks, 5 and 6 for now. Okay, moving on to solutions. Okay. So what proportion of students who own a credit card are freshmen? Okay. So number of students owning a credit card is just the sum of first row, right? Because 42 freshmen, 81 senior and 55 second year students are owning credit card. So adding them all, you will get number of students who owns a credit card, which is 178. Out of these, number of freshmen who owns a credit card are 42. And you have to tell the proportion of freshmen of all the students who owns credit card. So that's 42 over 178. Any doubt in this?
Yes, actually, when will we do 42 out of 300? What will be the question frame like that? 42 by 300, what proportion?
Proportion of students who own a credit card who are freshmen out of all students.
Yeah, what proportion of total students, I could have write, what proportion of total students who owns a credit card are freshmen?
Just
now,
add
for
the
42
total in
out
the
of
question.
300, what it represents, what proportion it is 42 by 300?
42 by 300 is the out of total students, number of freshmen who owns a credit card. Right?
Sir.
Yeah.
That's what I did. That's why I'm asking you.
Okay, the question will be something like what proportion of total students who are freshmen and owns a credit card?
Who are freshmen
and owns a credit card?
Sir, and 42 by 100?
42 by 100. Okay. what proportion of freshmen owns the credit card, right?
Okay.
Our main focus will be on freshmen only, but proportion of freshmen owns the credit card.
Is 0.23 a wrong answer?
No, it will be considered right, but as I said, just try to keep the answer well rounded to 2 decimal place. If you divide it, your answer will come out to be 0.235.
Okay,
So
right,
2
sir. I
decimal
got it.
place, it will be 0.24. Okay, so yeah, you just have to read the statement carefully. Here we are talking about what proportion of student who owns a credit card. So this statement clearly tells me that my main focus is only on the first row, the student who owns a credit card. Out of these, I have to tell that how many are freshmen or what proportion is freshmen. Right? Any doubt in this?
No, sir.
No, sir.
No, sir.
No, sir.
Okay, moving on to next. Okay, yeah, that's the main question. Is the row relative frequency similar for all rows? So from this question, we can also answer the association question one asked before the session.
Sir,
Yes.
actually, can we manipulate uh, this frequency table in like freshmen, sophomores, seniors in rows, and credit card yes or no in column?
Yeah, you can do that. It's the same thing.
Okay.
But the higher row relative frequencies are according to this structure only, not that structure.
Okay.
Even though you will get the same answer because
Yes, sir.
row
I am
relative.
getting the
Yeah.
same. I am getting the same. Sir.
Yeah.
So how many questions are there?
In total, I think 3 or 4 questions only.
Okay, sir.
A week for graded assignment is also pretty simple. Only 2 questions grouped. 96 have you answered? Okay, 15, yes.
But this grade GA4 is having too much calculations.
Yeah, calculation thing is heavy in this. Okay, you won't be having such difficult calculation into this, to be clear. Okay.
Sir, what is the correct answer for this one? And that the
Yeah,
row
I'm doing
frequency.
Credit card response, it is either yes or no. Okay. This is your freshman. Yes or no. This is your senior. Okay, why I'm drawing this table is total. Okay, whenever we are asking whether row relative frequencies are similar or not, okay, you also have to consider the total column. Okay, you have to create the total. You have to create the total row as well. And you have to check for all the 3 rows, not only these 2. Okay, you have to check for all.
Answer yes. Is this question answer yes, sir?
No, because okay, what will be the row relative frequency? Right? For that, you will need the row total for first row. Right? It will be
178.
Okay. And
122. 122.
300.
130. 130.
If you do it, it will be 42 over 178. I think we have also computed it earlier.
0.24.
0.24 for this, right? Next is 55 divided by 178, which is
0.31.
Okay. And next is 81 divided by 178.
0.46.
Okay. Next is 58 over 122.
0.48.
Yeah, 0.48. 45 divided
0.37.
0.37.
Okay, and for the last one, it's
0.16.
0.16. Okay. And here it's all 0.33, right? So as you can see, for the first row, it's the set is something like 0.24, 0.31, and 0.46. But for the second one, it's 0.48, 0.37, 0.16. These two are not similar, right?
So, sir, this means that there is a relation.
Yeah, it means the row relative frequencies are not similar over here. Okay.
Sir, actually here also like when we are saying the row frequency are not similar because the number itself looks very simple. Na? Like out of 100 it is 42, out of 100 it is 55, and out of 100 it's 81. So by that means also we can easily see that it is not similar across the rows, right?
Yeah, in this case you can see, but there are also data in
When
which
the-
you
okay.
In which it may seem that it will not be same.
Okay, but sir, like as you did here, like you calculate the total 100, 100, 100. Like in
Yeah.
all cases, we need to have the same kind of thing, 100, 100, 100. Or
Yeah, that's what I'm coming about. If even say for these 2 rows, the row relative frequencies are similar, but for total row it's not, then also you will answer no. Okay. You have to check for all the 3 rows. So you have to make this total row on your own and check it.
What, sir? Can you repeat once more?
Okay, when we are asking whether row relative frequencies are similar, right, for all rows, you don't have to check only for yes and no. You also have to make the total row on yourself and check for it as well.
So you said the row first and row second is similar. How these are similar?
No, I'm saying if in case these two row relative frequencies are similar for
Okay,
these two. Okay.
Okay. You are assuming a case.
Yeah, you still have to compute for total and check whether it's same from these two or not.
Okay, but in this situation, there is not similarity between the.
Yeah, there is no similarity because it's 0.24, 0.48 over here.
Right. That is my concern.
So in that case, if it is 0.24, 0.24 and 0.33, then the answer would still be no, is it, sir, then?
Yeah, it will still be no.
Oh, okay.
Yeah, so the total row is also.
With this data, we can check also association.
Yeah, that's the way to check association. If row relative
Sir,
frequencies are same. Yeah.
So, if you have to check for similarity for freshman and sophomore, can't we say it's similar because it's like increasing? Matlab 0.24, 0.48, and 0.33. Matlab like there's a pattern for
Yeah,
freshman and sophomore.
there is a pattern. Okay, so yeah, that's it. Whenever there is, see, there is no similarity, right? There is a pattern. As they are going to second year, it is increasing, right?
Yes.
So it means that these two variables are associated. As they move to second year and senior, their credit card responses keeps on increasing.
Okay.
Okay, so that's when we say when the row relative frequencies are not similar, there is an association. When they are similar, there is no association.
No, sir. I just I cannot understand how are you talking about similarity exactly.
Yeah, so how do we quantify that, sir?
Okay, let me just erase the frequencies. Okay, it will be better. So what was frequency over here? I think 0.46. Okay. See, if you can notice the pattern here, right? If they are in,
I have a question here.
Yeah, let me answer first. Yeah, if they are in first year, right? The proportion of students owning the credit card are 0.24, right?
Yes.
As they move to the second year,
Yes.
okay, their proportion of owning is 0.31. It's increased, kind of increased.
Okay.
Okay, and okay, I am talking in, okay, for here the similarity perspective which I am saying is from column point of view. I will come to it. Okay, as they move to the final year, their relative frequency increases. It means as they move to second year and final year, the proportion of them owning the credit card keeps on increasing.
Okay.
And you see similarly for no, it will keeps on decreasing. So you can see that there is an association, right? As the year of graduation increases, the credit card owning will also increase.
Okay.
So here you see that frequencies are not similar, right? For this column, for this column, for this column. If I talk in terms of columns.
Yes, sir.
For all three
What
columns.
frequency would be considered similar and what would be not considered similar? So how do we decide the range, sir?
Okay, wait. So yeah, here if I take the first column, it's 0.24, 0.48, right? It's not similar to the second column values. And it's not similar to the third column values also.
Sir, are we talking about any ratios like all? It is 1:2. Freshman, it's 1:2, and for sophomore, it's not. Near about nahi hai.
Yeah, you
1:2
can say
ke
that. You can also understand like that. It keeps on
that
increasing.
ratios should be similar, or is that sort of a similarity should be there?
Yeah, let's suppose the values are okay. Let's suppose it's the same value for every. Okay, 0.48, 0.24, 0.48, 0.24, 0.48. So you can see that as they move from first year to second year to final year, their proportion of owning and not owning remains the same, right? So increase in their year of graduation does not affect them from owning the credit card. So that's why we say when the frequencies are similar over the rows or columns, there is no association. But if you check the green one, you can see that it keeps on changing. So there is something to do with the year of graduation with credit card owning, right?
Okay.
Yeah.
Okay, sir, I understand.
So that means when we say a row level frequency, we are comparing the column, correct?
You are comparing the, yeah, if you can just take it like that, the first rows as one set and second row as second set, and then you mesh. Yeah.
Like when we do a column level frequency, we are comparing the rows, correct?
Yeah, kind of. Yeah.
My question is, will there be a situation where the row level frequency is different? So I'll say that association achieved. Since it is different, I'll say there is association. On the same data, will there be column level frequency will be same?
Yeah, if it's same for row relative, it will be same for column.
No, sir, it's the opposite talking. Row level frequency is different. So that I will say that association is achieved because it is
association.
different.
Yeah.
Okay. But on the same data, I'm asking in an imagined manner, for the same data, will there be a column level thing will be same?
No, it won't be possible.
Okay.
It's kind of vice versa thing. If this happens, it implies it will also happen.
Okay, that means the wrong data. Okay, fine. Yeah. Okay.
Yeah.
Thanks.
Yeah. It's the same thing. If row are same or similar, you can say different, same will be for column.
Okay. Got it.
Won't be the other case.
Yeah.
And you also have to check the total, no, sir? The total percentage.
Yeah. If you're doing column, you have to find the column total and then also find that relative frequencies.
Sir, in column relative frequency,
why
what
we
we are
total,
comparing?
Because already column row level we achieve, right? Why should we care about the total level?
No, this total is also a row level, right?
Yes. But anyhow, if the above two rows are matching, which is different, then total also will be different, right?
Yeah, total will also be different in most cases. I haven't seen any case till now where it's comes out to the same, but yeah, for sure. You can check.
Sir, if total is not different, let's suppose it is similar with above one row,
then also you will say that row relative frequencies are not similar, because even if one row comes out to be different, you say they are not similar. There is an association.
Okay.
Yeah. And the range for similarity, it's something up to you how you make decisions. But if you come to the quizzes exam, you will be given values which will be really close or really far. You won't be given such ambiguous value. Okay. In real life data, it's up to you whether to consider 0.20 and 0.24 as similar or not. It's up to you. But in exams, graded questions, quizzes, we will give you data where if you're getting 0.20 here, you will get something like 0.193, something like that. So there won't be any ambiguity in answering. Any doubt in this?
Sir,
Yeah.
one query regarding the second column. Please go on to that slide, sir.
Second column.
Yeah.
You're
On
talking
that
about
slide.
the whiteboard, right?
Yeah.
Okay.
Sir, if we look at the second column,
yeah.
So here we can say no, that relative frequency are same.
For
So very
second.
similar.
Yeah, but you can't see if you're looking at this column, right? This column observations are your 0.31 and 0.37.
Yes.
Which is
and
not.
the total is 0.33.
Yeah, 0.33, which is not similar to here. It's 0.48, 0.24, 0.48, and 0.33. It's
But
not
still,
similar to this, right?
I think when we approach to the lecture, so whenever we are calculating the row relative frequency, then we need to check the columns frequency, whether they are
Yeah, I'm
similar or
checking
not.
this with this with this, or this with this.
Yes.
Yeah.
So I'm particularly asking about this second column. So in second column, we can say na, that these frequencies are similar.
For second,
Only
yeah, only for
only
second. It's up to you. If you want to say that these are similar, you can say that.
but
0.31 and
overall it
0.37.
is not.
Yeah,
Overall
overall
it
it
is
is
not.
not. Yeah, overall it is
Yeah.
not. Only for one column it is.
Yeah.
Okay.
I have one doubt.
Yeah.
So here we are checking within the row itself, right? We are comparing within the row itself whether the frequencies are, whether the percentages are same or not, proportions.
Yeah. For all rows, we are checking column wise. Like for first row.
Row wise.
For each row, we are doing it column wise. You can say, like, if I am checking row relative frequency, I will check
And
0.24
each
with
column.
0.48 and 0.33. I will compare these three values.
It means only freshman data.
Yeah, only freshman data, then only this, then only this.
Yes,
excuse me, sir.
Yeah.
The for not means for not association, it's given the row relative needs to be the same. So sir, it should be exactly the same, or should the trend be same for all the rows?
See, it's up to you. It's not same, it's similar actually said. Okay. It's up to you if you want to consider 0.22 and 0.25 similar or not. This in real life data, if you work on, it's up to you if you want to consider them as similar or not. But if you talk about here in this course, we won't give you such data where you will get this value. Either you will get very close or very far. There is
So
no
sir, like 0.19 and 0.20, we'll take it as
Yeah.
similar only.
Yeah, we will take it as similar.
Okay, sir.
Okay. Okay, moving on to next. I think you can answer it only in a minute. Is column relative frequencies similar for all columns?
Will not same, na sir.
Yeah, it's if row is not same by the column.
Because row relative is not same, then column also by default will not be same.
Yeah, you can say that.
Hello, sir.
Yes.
Sir, I didn't get you. Why is it mandatory to check for totals also if we already know that it is different?
Yeah, it will come out to be different for total as well, but just for surety you can check. Like it's
So
kind
once
of
it is
necessary to.
different, so
Yeah,
why?
once it's different, even if let's say there are 5 rows, okay? Even
Yeah.
for first 2 rows it's different, you don't have to check any other row.
Yes, so
Yeah.
it will just consume time now if we
Yeah,
go
yeah.
on.
Yeah, but I'm telling the general methodology which is followed. It's up to you if you want to check it or not. Even if 2
Okay.
rows are different, the answer will be not similar, straightforward.
Okay, in practical scenario, we should check for all of
Yeah,
them.
yeah, you have to check all of them.
Okay.
Okay, 10 people still answering this. I don't know why. Okay, so we have already checked that row relative frequencies are not similar, which also implies that column relative frequencies will not be similar. You can also verify that by computing the values.
Sir, one small doubt here.
Yeah.
So like in practically, how is it related to like in practical applications? For example, At any condition 100, if I calculate with, I compare with regard to the total one, at any condition it will not be similar. Maybe one or two cases it can be similar. But how do I relate to the practical application of the relative frequencies, similarities along column and along rows? What is the practical application of this? Could you please give an example?
Okay, if we stick to this course only for now, the practical application for this problem is to find, as the student keeps on, moving on to second year or final year, whether their owning of credit card increase or not. If I am selling credit card, this data is important for me. I know that my main target will be the final year students only. If I want to take some chance, I will go to second year, but for freshmen, I may not go and waste my time. So whenever these are such categorical variables, we cannot find correlation coefficient for them to find if there is association or not. So we stick to this row relative method or column relative.
So like it means like predicting the behavior of a customer buying behavior, whether he will go for in the first year or
Yeah,
second year.
if you have to sell credit card, you must know what is your audience in college. If you want to sell in college, you must know like whom to target and whom to not. Like if I have less time, I will go to final years only. If I have little bit more time, I will may or may not go to second year. In freshman, there are very less chances. I will consider in last.
Okay, thank you, sir.
Okay, so that's the main question. Is there any association between the year of study? I think I've already answered it. Still, take your time.
Associations will tell us what is the strength of the association. Okay, now
Anand Barla, you can leave the session and what? Okay.
Anand, please mute.
Him, I think.
Please mute.
No, I am removing him from the meeting. No worries. Okay. Let's see. Is there an association? Okay, yeah, 70 people still responding. Okay, we have already checked that row relative frequencies or column relative frequencies are not same, or you can say similar for all rows and columns. So the two variables are associated with each other. We have already discussed it so far. Anyone still any doubt?
Sir, I just got not a clarity idea. Like if the row frequencies are not similar or the column frequency not similar, we can say the association is there or not there.
Association is there. Okay, see. It's a mess. Okay. This green ones are row relative frequencies. Okay. Here you can see that these are not same for each row, right?
Yes.
So it means that as the students, okay, you see that it's not same, but it means by it not same, it means that as the student keeps on graduating, their chances of owning credit card keeps on increasing, right? From 24, 31 to 46, right? So I can say that, okay, yeah, there is something to do with their year of graduation with owning the credit card. I can conclude something like that from this data, right?
Like similar means no association?
Similar means it's same for everyone, right? All freshmen, there is same probability of freshmen, final year and second year student owning a credit card. Then it means the year of graduation won't be affecting like whether they own a credit card
Yes,
or
yes,
not.
yes, I got it.
That's why we say it's not similar. There is an association. Okay.
Okay.
Excuse me,
When
sir.
comes to
Means for second row,
Yeah.
how can we can say that for second row this is true? If we just go by means row relative frequency are increasing, means for second row relative frequency is decreasing actually.
Yeah, it will decrease, right?
That
Because not owning will keeps on decreasing if keeps owning keeps on increasing, right? It's the vice versa thing.
okay.
If more people keeps on owning, then less people will be not owning. Okay. Yeah. Moving on to second question. Okay, there are two factories A and B, and they produce the square-shaped wooden sheets of varying length. You have to find what is the population standard deviation of measure of side. Measure of side is the second column in this table. True only. Okay, it's not true that only 35% people pass. Okay. Okay. Here you can see that the data for measure of site and calculating population standard deviation for it is pretty easy for this data. So only such data will be in quizzes, not the heavy data.
Done, sir.
Done, sir.
Done, sir.
Do you guys need more time in this?
No, sir. Done.
No, sir.
No, sir.
We're
Done.
done.
Done, sir.
Increase it by a minute only. 50% responses are there by now.
Done.
Okay, let's move to the solution. Okay, who is answering this 2, 5? I think there is someone who is keeps on entering random values. We have to take some action against him. Okay, most of you have answered. Okay, so if you see that here the mean of the data will comes out to be 5. Okay, mean is nothing but summing these 5 observation and divided by 5. Okay, mean will come out to be 3, sorry. Number of observations are 5. And then for population standard deviation, as you all know the formula, we need to find xi minus x bar and then square it. That's what we did in the next 2 columns. And then we take the sum of xi minus x bar whole square and divide it by n. And then you have to take the square root of that because it's population standard deviation. Had it been population variance, you don't have to do the square root part. Any doubt in this?
No, sir.
Okay, these type of data sets, yeah, you can expect in qualifier.
But if in GA also, if this type of there, that's good, right?
In graded, you don't have any time restrictions or something. So you can do such heavy calculations there also.
But anyway, in future, we will do all thing in spreadsheets and Excel. Now we won't do anyway with calculator. So it's really difficult to do these calculations.
See, you are currently the foundation level. So in foundation level, we assume you expect you to go by the basics calculator and all that. As you move on to diploma degree level, you won't be using calculator.
वही तरीका है जैसे बचपन में टेबल याद कराई जाती थी.
Yeah, you can say that. You have to just go by basics first. That's what the foundation level means. Okay, question number 2 is, what is the sample standard deviation of the same? Okay, don't try to go by the formula, try to use the relation between the population and sample standard deviation. You may expect some question where you will be given number of observation and population standard deviation, and you have to find the sample standard deviation. You won't be given data. So try to find the relationship between the two. You can expect such question in qualifier. Okay.
I have a doubt here.
Yeah.
In the column 1 factory,
yeah,
there are 2 factories, A and B.
Yeah.
So how it would be if I group the measure of sites for the factory A as 8 and B as 7 and then take the standard deviation?
No, we are not asking anything dependent to the factory. We are asking in general.
Because the outcome from the factory A is 5. Sorry, outcome.
Yeah, but here in the question, it's a general thing, right? We are asking about the general data. We are not taking factory into consideration. We will take it in further question. But for now, we are not taking factory or area in the consideration. Okay. Yes, Divya, you have raised your hand.
Sir, I have a general doubt, sir, regarding this week. So in week 1, week 2, and week 3, I have scored above 40%, sir, now. So now there is no any compulsion, no, sir. If I score less than 40 in this week 4 also, it's okay. I'm qualified, no?
I don't know the exact terms, but yeah, I think it's 3 out of 4 you have to qualify, as far as I remember. You can check the document given to you. Student handbook.
Okay, it's given, sir, but still I want to confirm that, sir.
Yeah, if it's written, then yeah, it will be only
Okay,
3
sir.
out of 4.
Thank you, sir.
Sir, one question. Like earlier when we were doing the percentile, we found outlier through a particular method. Hello. Sir, I have a question.
You are the one playing, you are joined from different ID, right?
No, I'm Anand Balla. I'm from the same idea.
Okay, why were you playing the lectures in the class?
No, that accidentally that happened, right? So it's not playing now.
Okay, yeah, continue.
My question is, earlier when we were doing percentile, so we found outlier through the particular method, right? 1.5 IQR.
Yeah.
We have similar things related in week 4 also, right? We have in the graph we have to find the outlier. So here we have to do just visually, right?
Yeah, it's just a visual thing.
It's only visual thing, right?
Yeah, it's just
Okay.
to give you idea of some real life, like how you do. It won't be in graded or quizzes, but yeah, it's just to give you some idea, like how to visualize the graph.
Okay. Thank you. Thank you, sir.
Sir, how many questions are there?
In total, there are 4 questions as far as I remember. We are on question 2 right now.
Hello.
Sir, is this similar question
Hello.
of previous?
Sir, I have one question. Suppose.
But this question similar to?
Hello.
Of previous question.
Yeah, in previous question, we were asking population standard deviation, right?
Yes, this
Here you have to
question
find-
sample.
Yeah, you can find
Sample
by the
deviations.
formula also, but I
Okay.
want you to use the relation between
N
the
minus 1.
population. Yeah, you want to use the relation between the population and sample. Okay, because in the exam,
But what
you
is
can,
the relation?
yeah, that's what you have to find. In the
Sir,
exam,
I'm
it is
not able to-
possible that it is given population standard deviation is given to you. Okay, number of observations is given to you, and you have to find the sample standard deviation. You won't be given the data. So assume this question like that.
Okay, sir.
Sir.
Sir, I can see in the week 4 practice assignment, there are many questions have lengthy calculations.
Yeah, because it's every question is different for everyone. No two of will be getting the same question. That's very rare case. So we can't keep calculation simple for that many variations. So it's just a random data we are given to you. So calculation can be heavy or can't be for some cases.
Yes, it's really time consuming and small error also making missing decimal places, digits.
Yeah, it's a random data, right? Because if we give same questions to everyone, there are heavy chances of getting copied. So we give different data to everyone, and the data is, that much randomly generated that even we can't control the calculation for that. It's something like that. Yeah. So let's move on to the relation.
Hello.
Yeah.
Yeah, I have one general question. Suppose my assignment score is below 40 out of 4 weeks in 1 week, only in 1 week, and rest other weeks are more than 80%. So I mean, I will be eligible or not?
You can check students handbook or ask the support team for that. I think they will tell you the better.
Okay.
I have no idea on that. Yeah. Okay, so this is the formula for population variance, right? And for sample variance, it's, let's see, note by small s. Right? If from the first, this thing, if I multiply both sides by n, I will get n times sigma x squares equals, right? Now if I plug in the value of this thing over here, I will get sample variance equals n times population variance upon n minus 1. And if you have to find standard deviation, I will take the square root on both the sides. Okay, so if there is some question where n is given to you, population standard deviation is given to you, you can directly find sample standard deviation by using this relation, even if data set is not given to you. Right? Or vice versa. Sample standard deviation is given and you can still find the population variance.
Give me 1 minute time to note it.
Yeah. Any doubt in this?
No, sir.
No, sir.
Can we, quick question related to qualifiers, can we use Google Sheets in qualifiers or that's
No,
banned?
no, it's not allowed. Only TCS calculator. Okay, if have you guys done week 4 bonus practice assignment, then also you can get better idea of these concepts. These are used over there. Okay. Okay, shall we move to the next question?
Sir,
So just 1 minute.
Yeah,
please
sure.
wait.
Okay.
Done, sir.
Sir, please wait.
Okay.
सर ऐसे रिलेटेड और भी फॉर्मूले हैं
For this before I think it is
Sir,
the
can you
relation.
just explain it once again?
नहीं सर जैसे वीक 3 में आपने वो वेरिएंस का बताया था फॉर्मूला सैंपल वेरिएंस सैंपल
opening. Yeah. There are various such tricks we expect you to use at the time of exam.
तो सर वीक 4 तक अभी सिर्फ यही दो ट्रिक्स है ना
Yeah, till week 4. As far as I remember now, these two are there.
Sir, may you write again the variance formula?
Okay.
Yes, sir, please.
Variance formula, which the
Last
opening.
week, what he was telling.
Last week, you there.
Okay, 1 minute. Someone was asking this. After this, we will do that.
Last week, the timestamp was 50th minute. You can go and check, na? 45 till 55, 10 minutes. He was explained.
Okay, so population variance formula, you all know this, right? If I multiply both sides by n, I will get n times population variance equal this summation thing, right? Which I calculated from data. You can also verify this relation if you want. For sample variance, I know the formula is this, just n replaced by n minus 1. If I substitute the value of this summation, which is n times population variance over here, I will get sample variance equals n times population variance upon n minus 1, right? And if I want to know the standard deviation, I will take the square root on both the sides, which will give me sample standard deviation equals population standard deviation times this term. Right? This term. So any two things given to you, you can find the third, right? Okay, someone's asking. Okay, the population standard deviation, population variance formula is this. You want me to do the complete opening or just the final formula?
सर फाइनल फॉर्मूला
फाइनल फॉर्मूला
सर सैंपल और पॉपुलेशन दोनों को बता देगा
Okay, and for sample we just replace the denominator n by n minus 1. Rest all thing remains the same.
Sir, is it the same formula like when we are getting the mean, then difference, then square difference, sum of square difference, then sum of square difference divided by count, which we are getting variance? And when we're making the square root of variance, we get the standard deviation. Is it the
Yeah.
same formula or is it different one?
You take deviation of each observation from mean, square it,
Yes.
and then divide it by n.
Yeah, divided by n, then we get the variance, and the square root of variance, we get the standard deviation.
Yeah,
right?
yeah.
So that is for the sample one or population one?
For the population one, if you divide it by n minus 1, it will be sample. It will divide by n only, its population.
Thank you, sir.
Only difference, yeah. Can we move further?
Yes,
Yes,
sir.
please, sir.
Okay, so this relation is also written in the slides. You have to just plug in the values and find the sample standard deviation. You can verify it also. Okay, moving on to this. What is the sample standard deviation of area of wooden sheets?
Sir, in previous one, using formula, I got 1.169.
Just check your calculation. I think it's correct over here.
It is means 5 by 4, right? And after that, we will multiply the previous one. It is 1.095.
Yeah. Okay, it's possible we made calculation error over here also, but yeah, this is the formula, the main thing.
Square root of 5.
Yeah, square root.
Okay, yeah.
Sir, one small fundamental doubt. Sir, that when we're calculating the standard deviation and the variance, so sir, where exactly we are using this standard deviation variance? Like, what is the application of this thing? Like practically, how we can understand this?
A variance, it just tell you like what is your variability in the data, like from the measure of central tendency, which is mean we consider here. So how much your values are deviating from the mean, it tells you. But the problem with variance is the units of variance will be square of that, right? If your data is in meters, the variance you will find is in meter square. So that's why we use the standard deviation also, so that we get the variability and data in the same units.
Okay, sir. Thank you.
Done, sir.
Sir, I have some doubt regarding bonus assignment.
Okay, which week?
Week 4.
Okay.
Actually, sir, the confusion is like, there is a question where the simple interest is given for A and B, right?
Yeah.
The sample standard deviation is given for A and B, and their covariance is also given between A and B. So the question is, number of observations are also given there, right? The question is, based on this given information, answer the question 1, 2, 3. The third question is, from the given list of options, select the option number which represent the relation one can use to compute the unitless measure of linear relationship between simple interest A and B.
Yeah.
Actually, see, the options are 5, 6, 7, and 17 are the correct options, right?
Yeah.
So 5, 6, 7 is okay because some formula is written there. The formula is written there, right?
Yeah.
But in option number 17, only correlation is written. So it is really confusing. I mean, how to select the options. Simply correlation is written there, right? But still it says that is also true.
Because that's also unitless measure, right? We are asking about what is a unitless measure to find it.
But okay, if similar things coming in the formula also, right, where we are multiplying covariance and dividing by standard deviation.
Yeah, you have to select all of them, whatever applicable.
Okay.
There is also one question you have to select all which can be used to compute correlation coefficient, right? There also you have to select covariance, all those relations, whatever possible.
Okay.
Like we can use sample variance can also be used to compute. Population variance can also, you have to find it all.
Just
okay,
1 minute, I didn't enter my answer.
Yeah, sir. Then this covariance, what exactly it means, sir?
What thing?
Sir, you told me about the variance and the standard deviation. But you told again now you are telling some covariance. So, sir, covariance, why does it play, like what exactly?
A covariance also tells the linear association between the two variables. But the problem with covariance is it has some units.
Okay.
So you can't, suppose for one it's kg meter and for one it's kg liter. So you can't compare those two covariances, right? Because they are not in the same units.
Okay.
So that's why we use the correlation coefficient, because it don't have any units. So we can check, okay, if this having correlation coefficient 0.5 and someone having 0.6, we can say that, yeah, this relationship is quite stronger than that one, which we can't do with covariance.
But sir, then we can go directly for the standard deviation where we will have the clarity in, like, in terms
standard
of the
deviation tells you the variability from the mean, right? Here I am talking about the association, linear association between the two variables, like how the increase or decrease in the one variable affecting the increase or decrease of other variable linearly.
Okay, so in that cases covariance comes into picture, but covariance because the units are different, so we need to go for the
some unitless measure, which is correlation. Okay, so yeah, this is the same thing. You just have to put square root and n-1 in the denominator, the same calculation. Any doubt in this?
So calculation is very hectic.
Yeah, for this it is. Okay.
No, just
It is
I want to
something
know
like graded
one girl.
assignment.
One girl is doing very quickly. How she is doing? May I know? That
She's
much
using Google
quickly?
Sheets, maybe.
She is using Google Sheet formula.
Yes, Google Sheet.
Can I expect reply from her? Because immediately she is telling. That's what I surprised. How with using calculator also, it's not impossible.
Okay, let's not go into that. Okay, yeah. Next is covariance and correlation. Okay, so covariance, as I mentioned, it strength of linear association between the two numerical variables. But covariance do have units. You can't compare two covariances because it is possible that they might have different units. That's why we have another unitless measure of linear association, which is correlation. So the Pearson correlation coefficient is given by this. There are many other correlation coefficients, Spearman rank correlation coefficient, and many other. But in your syllabus, it's only Pearson correlation coefficient for now. Okay, for two numerical variables. Okay, and also focus on this word linear association. Okay, let me give you a brief idea about this linear thing. You all can see my screen, right? The Excel sheet.
Yes, sir.
Okay, let's consider some data. Okay, let me consider y is equals to x square. Okay, these two variables are also related, right? And if I plug in some value, y and x, okay, -3, -2, -1, 0, 1, 2, 3. X is Okay, this is x and this is y. Y is just a square of x. Okay. And if you find the correlation between them, why it's, I think I made some mistake.
सर आपने x भी ले लिया.
Range second.
Yes, you have taken the x also.
Okay, you see that correlation coefficient coming out to be 0 over here, right? Even though there is a relation between y and x, but correlation coefficient tells us about the linear association. So if there is any other relation like quadratic or cubic relation, it is possible for R to come 0. Because if correlation coefficient is 0, it means they are not linearly related. That's the only statement you can say. You cannot say in general that these two variables are not related. I have shown you this example, right?
Sir, I got confused. When you are saying y is related to x, okay, we are getting the x value -3, then y value 9, like that. So
Yeah.
when you're saying linearly they're associated, means what exactly it means, sir?
A linear association means if they are related in some linear equation sense. Let's say this.
Like y equal to x, yeah.
Y equal to 2x plus 3, something like that, some linear relation, right? That's a quadratic relation. So correlation coefficient don't tell you about the quadratic, cubic relations or any other relation except the linear relation. It only tells you the strength of linear relation.
So that means when R equals to 0, it means there is no linear association.
Yeah, no linear association.
So some association is there, but it's not linear.
Yeah, some association can be or cannot be. You can't say.
Okay.
But
Yes.
linear
Yesterday,
association definitely not.
I think day before yesterday we were discussing this.
Okay, so then linear association, how did you calculate it became 0? Like, is it adding all the values or this formula?
It's the correlation coefficient. I just plug in the formula.
Okay, then when a linear association says 0, there is there may be other association is
can be maybe possible. Okay, so whenever in some question it is mentioned that correlation coefficient is 0, the only thing you can answer is they are not linearly related. Don't answer they are not
How
related.
can we identify there is a linear association? Here R is equal to 0.
Yeah, means no linear association. Okay, let me write it. So for linear association, right, we find the value of R, right? If my R lies in the range of -0.25 to, well, let's take the absolute value of R for now. If it's in this range, we say absence of linear relationship. Okay. If it's in this range,
Strong.
It's weak linear relationship.
Weak.
If it's in this, it's moderate. And strong. I have to check this equal. Either it's this side or that side. I don't remember exactly. I will check and get back here. Let's move it for now.
Are less than equal 1. Third line, sir.
सर दोनों साइड वो लेस देन इक्वल्स टू होता है.
नहीं दोनों, not both side.
Not both sides, but are less than equal 1. 1 is included strong.
Only it is right side, I think. Right side is equal.
Yeah, as
Yes,
far as I remember, it is.
right side.
Okay, let me confirm.
One is strong relation, na? Yeah, one is strong.
For here, it's on both. But yeah,
Excuse me, sir.
yeah.
So, core, so linear association is stand only for correlation or covariance?
By using correlation coefficient, okay, we compute the value of correlation coefficient, which is R, and on the basis of value of R, we tell whether there is absence, there is a weak or moderate or strong linear relationship.
So we cannot check for covariance.
From covariance, you cannot check because covariance have different units, and there is no hard and fast rule in covariance like in correlation.
Okay.
Sir,
Okay.
one more fundamental
Yeah,
doubt, sir.
equality thing, I will check and get back. Let's not write it here. Okay, yeah.
Sir, one fundamental doubt, like central tendency and mean, is the what are the difference or both are same only?
A mean is one of the central tendency.
Okay. So what if central tendency means what exactly then we mean?
Central tendency means suppose this is my data set. Okay, what is the value which will balance this data? What is this center of seesaw? You can say consider this data as your seesaw. What is the central tendency value which will balance it? Okay. Okay, moving on to, let's move on to next question. This linear association thing is clear, right?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. The formula
Yes,
for
clear.
calculating covariance.
Formula for
Covariance means there is no formula for covariance.
covariance, there is formula, right? Okay, okay, let me. I think my screen is not present. Okay, you want to know about the covariance?
Yes.
So covariance of, we have again two things: population covariance, which is 1/n summation of product of deviation of x and y from their respective means. And for sample, it's n-1. Okay.
Okay.
And the correlation thing, which we are doing, right?
Pearson correlation.
Yeah, Pearson correlation. It's either this population covariance, okay, okay, of x and y divided by population standard deviation of x and population
standard deviation.
Yeah, it is also same as you take sample covariance in the numerator and divide by sample standard deviation of x and sample standard deviation of y.
Okay.
If you plug in value in any of those, you will get this formula only. The n or n-1 parts get cancelled. In this case, n gets cancelled, n-1 get cancelled. These are the three formula for correlation coefficient you can get. Okay.
Okay, sir.
Okay, yeah. Okay, moving on to the question now.
Sir, one doubt. We don't want to divide by n minus 1 or n. So directly we can apply that equation and do.
Yeah, okay.
Because I wrote wrong in the practice similarly because.
Let me do it for. Okay, let's say you are doing it by population. Okay.
Yeah.
By sigma x, sigma y. Okay. If I plug in the value, it will be 1 over n summation xi minus x bar.
Minus
right?
x bar into yi minus y bar.
And sample standard deviation is population standard deviation is
xi minus x bar the whole square into yi minus y bar the whole square.
okay. If you notice over here that it's square root of 1 by n multiplied the square root of 1 by n, which is nothing but 1 by n.
Okay.
So this gets cancelled out.
Okay. So, sir, one more doubt. We can find the covariance and we can divide with the sample standard population standard deviation and this thing yi also. That way also we can find, or simply we can apply like without dividing n minus 1. We can directly do this one.
You can directly do this one. It's up to you. You can use any of the three formula.
Okay.
Okay, yeah. Moving on to the question. See, by now we have calculated sample standard deviation of this x and this y over here. Now we have to find the sample covariance to get the correlation coefficient. That's why we now have to find sample covariance between the two.
Sir, done.
Done, sir.
there's no point in solving this question. The data is y is equals to x square.
Okay, yeah, I will show you this thing also. Yeah, but that's not always the case. That's for large data sometimes. Okay, I will show you. Someone was also saying, like Sakshi, Sony, you were also saying something, right?
Sir, I have a question regarding row relative frequencies and column relative frequencies.
Okay.
I want to ask, sir, suppose if we want to find an association, whether suppose a smartphone is dependent upon gender or not,
Okay.
can we derive it through only row relative frequencies, or we have to calculate the row relative frequencies as well as column relative frequencies?
You can derive it through any of them, either of them, like either row or column. You don't have to do both.
Okay, okay, sir. Thank you.
Okay. So do you guys need more time in it, or can we move to solution?
Sir, please go ahead, sir.
Yeah, we can move ahead, sir.
Okay. 11 and 0. Okay, I think most of you have answered 0, but it won't be the case here. Okay, so we have to just find the value of xi minus x bar first, and then yi minus y bar, and we have to do the product of them and add them. So adding them and then dividing by n minus 1, because it's sample covariance, we will get 10.5. Okay. Any doubt in this?
Sorry, sir, can you repeat? X minus x
Sir,
bar
it is coming
summation would be
9.90, no?
0.
Xi minus x bar.
And the summation of xi minus x bar is 0.
Yeah, it will
So-
always be 0. In every case, it will be 0. Ya minus y bar. Okay, so that's the property, you can say, a kind of. Yeah, that's also a good thing to notice. When we do this thing, right? Xi minus x bar, right? If I open it, it will be summation xi minus summation x bar, right?
Yeah, okay, sir.
Summation, if you know the formula of mean, it's 1 over n summation xi. So summation xi is nothing but n times x bar. Minus, if I keeps on adding x bar n times, it will be nothing but n times x bar, right? It means I am adding x bar n times, right? It's a constant term.
Okay, no, we mistook the sigma to be individual one. Yeah, maybe in the formula. Maybe I did it that way. I mean, instead of multiplying and then we have to do the addition.
Yeah.
Okay. Sure,
Yeah,
sir.
this thing will always add up to 0. Yeah, you have to multiply and then add. And then you have to find, what can you say about the measure of, okay, correlation between the measure of side and area of wooden sheet.
This calculation will take time. You can go ahead, I think.
You have already computed covariance, right? You know the sample covariance.
Okay.
We have already computed the sample standard deviation.
Okay.
For both of them, you can just plug in, right?
सर
Yeah.
सर अगर मान लीजिए सैंपल कोरिलेशन कैलकुलेट करते हैं?
There is nothing like sample and population correlation. It's same.
हाँ मतलब तो जो सैंपल कोरिलेशन का वो आएगा एसोसिएशन
Okay.
वो सेम होगा ना पॉपुलेशन कोरिलेशन से?
These are some inference thing which we will cover in stats too. Okay.
नहीं अब इस केस में हो रहा था ना तो वही मैंने पूछा.
Or like how is it same? Like you don't have any population or sample data, right? You know only about this 5 observation.
Yes.
Excuse me, sir.
Yes.
Sir, one small doubt, sir. Like in the questions, it's given like we need to calculate answer up to the 3 places of decimal.
Yeah.
So, sir, we will round it off at the last place, or we'll start the calculation. It means every step will start do the rounding part.
Round it in the last always. Keeps on going in fraction as long as possible.
Sir.
Okay, so no, sir, like the things come like 1.24596. So like 5 decimal places. So do we need to
Don't
calculate
go in
it
decimal,
5
keep it in fractions. Right? When you have to find when you reach the final step, then go in the decimal for that. Else stay in the fraction thing only.
Okay, sir.
That's the best practice to do.
Okay. Thank you, sir.
Sir,
can you please show me solution for question 1, the previous slide?
You can go through the slides again. Let others answer this one.
Sir,
you want to know the value of sample covariance, right?
No, sir. I just want to know what is the mean of that X observation and Y observation? Because my mean is something different.
Okay, for X it's 3. If you are taking X as measure of side, and for area of wooden sheet, it's 10.2. 10.2.
सर.
Yeah.
सर अभी आपने बताया था कि नंबर ऑफ ऑब्जर्वेशन पता हो और पॉपुलेशन स्टैंडर्ड डेविएशन पता हो तो सैंपल स्टैंडर्ड डेविएशन निकाल सकते हैं.
Yes.
सर अगर उल्टा हो कि नंबर ऑफ ऑब्जर्वेशन पता हो और सैंपल पता हो.
Yeah, you can still do that. If you plug in those two values in the relation we derive, you can find the third one, right? Okay, I will show it after this timer.
Okay, sir.
Excuse me, sir.
Yeah.
So is this Vicky, sir? Here?
No, Vicky sir is in maths.
Oh, thanks. The voice is very similar to him.
Okay, yeah. Moving on to solution. If you find the value, it will come out to be 0.993. And since it's greater than 0.75, there is a strong correlation between the two. Okay, so first let me answer this. Why, even being the square, there is a strong relationship. Okay. Anyone know the graph of y equals x square?
Everybody knows, we are learning maths from that.
Parabola, sir.
So, okay, here the values are, let me see, here values are 2, 3, and 5, right? Okay, we can do it on Excel. I think it's better over there. It's 2, 3, 5. Okay, see, that thing is also possible, but here you have seen the data is very small. 2, 3, 5, 2, 3. I think this is the data, right? 4, 9, 25. 9. Okay. I will insert some graph. What can we get the line? Yes, good. Okay. So see, if you see that for this data, if you see there is a straight line following, right? Because whenever we draw for, let's say, y equals x square for positive values, right? My data will go something like that. So for these value like 2, 3, and 5, it kind of remains a lot linear, kind of remains like a straight line. That's why there it's coming out to be strong association. Okay. But if you keeps on increasing the value, like if you have more values like 10, 11, 12, then it won't be linear. It will take the parabola form over here. Okay, any doubt in this?
So sir, the correlation coefficient, the right side, there is no equality. In left side only equality, isn't it, sir? Here you mentioned.
I have to check in it. Yeah, I have to check that. I'm not sure. Okay. Okay, someone was asking population standard deviation, right? This formula is clear to you, right?
Yes, sir.
Okay. So if I multiply both sides by n minus 1 and then divide both sides by n,
चाउमीन बेचे ना तो ठीक है दे ले हम
डिवाइड भी किया है आपने. ओके.
then I can get the reverse thing, right?
Okay, sir. Got it.
Okay, yeah. So yeah, you can't directly say by looking at the squares that it's 0. It is possible in some cases, but in some cases it can be also. Okay, let's this point biserial correlation coefficient. Whenever we have one categorical variable and one numerical variable, we use this. And one condition more is our categorical variable must have only 2 categories, not more than that. So the formula written here is the correct one. In ma'am's lecture, it's sample standard deviation in the denominator, but it won't be here. It will be only population standard deviation. Okay.
Sir, in the question, if nothing is mentioned, then we'll find the population.
Like what type of question?
Yes, I saw practice assignment. There is no mention about sample or this thing.
What thing, like variance?
सर नहीं, डिनोमिनेटर की बात कर रही हैं कि मतलब अगर जैसे डिनोमिनेटर में ना दे रखा हो कि सैंपल लेना है कि पॉपुलेशन.
No, I'm telling you the formula for point biserial correlation coefficient is you have to divide by population standard deviation always.
Okay. Okay.
In ma'am's lecture, I think it's sample variance of x, but for that there is changes in the value of p0 and p1. Okay.
Both will give the same result.
Sir, in practice assignment, correlation only, sir. They didn't ask population or sample.
In correlation,
directly.
there is nothing like population or sample. Correlation is same.
Okay, sir.
Let me
Sir,
tell you
in
what.
this formula, excuse me, sir.
Yeah.
Sir, in this formula, we have to take only population standard deviation, no?
Yeah, take the population standard deviation where p0 equals, and proportion, or you can say uh, number of
Proportion.
observation belongs to category 0, right, upon total number of observations, and P1 is this, right? In MAM's lecture, it's sample standard deviation in the denominator. Okay, that's also correct, but for that you take this.
Yeah.
Okay.
Yeah. Thanks.
So yeah, try to use that and keep these things simple as much as possible. So yeah, I think that's the last question for today. You have to find is the measure of side weakly influenced by the factory. Again, one thing to boost you for qualifier is those who clear will get to attend Professor Usha ma'am's session. She will be taking few session in week 5 to 8. So, yeah.
सर कब लेंगे और when she will take?
I after week 6 or week 7 she will have one.
After
Before
qualifier, after qualifier.
Yeah, in between qualifier, after qualifier and before quiz 2 period, you will get to attend her sessions.
Evening sessions, sir. Evening.
Evening sessions.
After 7.
Okay, yeah, it depends mainly on the ma'am when she is free.
Actually, statistics is feeling little bit difficult. We don't know how
No, actually, it is a
qualifiers
lengthy
will be.
calculation only, sir. Other than that, we can manage.
The concepts are pretty simple. In quizzes, you won't be having such lengthy calculations. If you are clear with concept, you will be solving the paper in 40-45 minutes.
Even proportions also sometimes its comprehension is little bit tricky.
Yeah. For
But
that,
can you, just a suggestion, can you take one session only with that type of problems where 2 variables has been given and can in the week 3 practice assignment, question number 4, can you please open if you don't mind?
Students said after this we will open.
After this, okay, sorry.
Just let me put the timer. Yeah, let's.
सर 0.75 से अबव रेंज होगी पॉइंट बाय सीरियल की, तो
It's weakly influenced, not strongly.
ओके ओके.
Okay, let's. Okay, it is a kind of tie. Lost. Okay. Wait, you guys know what to take P naught? What is?
Sir, actually, I could not understand this question. So could you please explain this one?
Yeah. Okay. If I write down the data, it's factory A, P, and A, right? And the values are 2, 3, 5, 2, 3. Okay. Now it's up to you whether you want to take A as 0 or B as 1 or the reverse. Okay. Here I'm taking A as category 0 and B as category 1. Okay. The number of observation in my category 0, it's 1, 2, and 3, right? And for category 1, it's only 2. Then I know that P naught is nothing but number of category belongs to category 0 upon total number of observation, which is 3 by 5 or 0.6, you can say. Similarly, P1 is nothing but 2 upon 5, which is 0.4, right? If you remember the formula, it's y0 bar minus y1 bar upon sigma x P0 P1. By now, we have found the value of P0. We have found the value of P1. Okay. Next is y0 bar. Y0 bar is the mean of values which belong to category 0. 0 is category A. So mean of these 3 observations, which is 8 by 3. Next, your y1 bar is the mean of observation which belong to category 1 or category B. 7 by 2. We have the value of y0 bar and y1 bar. The only thing we need to find is sigma x. Sigma x is nothing but the population standard deviation of all these values. Okay. This thing you have already computed before. So yeah, just plug in all that, you will get the value of this. If its absolute value lies between 0.25 or 0.5, we can say that yes, it is weakly influenced. Right?
Yes, sir.
Any doubt in this?
No.
Okay.
Yes, sir. Yes, sir. I got it.
Yeah.
Thank you, sir.
The answer is 0.371.
Okay, let's see the answer. So these are the values we have computed.
Minus 0.
0.7. So it's in between the range of 0.25 and 0.5. So yes, it is weakly influenced by the factory. Okay.
Sir, can you please tell me what are the interpretation for other ranges? So less than 0.25 or greater than 0.5.
Okay, if it's between 0 and 0.25, it's absence of linear relationship. Okay. If
Hello,
it's
sir.
between 0.25 to 0.5, it's weak. If it's between 0.5 and 0.75, it's moderate, and greater than 0.75, it's strong.
Oh, okay, sir. Thank you.
Yeah.
सर
Yeah.
सर मैम ने बताया था कि एब्सोल्यूट वैल्यू पिक करते हैं y0 और माइनस y1 बार.
Absolute value.
हाँ.
It's for the finding the absolute value of
मतलब y
correlation
बार.
coefficient.
नहीं नहीं, ये पॉइंट बाय सीरियल में.
Yeah, no. if we want to find the absolute value of correlation coefficient, then we take the absolute value of this. It is because if you interchange it, right? If you take A as 1 and B as 0, and suppose in this case your answer was coming 0.37, okay? And if you reverse this category, your answer will become minus 0.37. So that's why we prefer to take the absolute value of correlation coefficient, point biserial correlation coefficient.
So sir, 0.37 and minus 0.37 both are same ki different answer?
Both are different. It depends on which category you are considering as 0, which was 1. But in general, we always ask the absolute value of point biserial coefficient. Because
Negative doesn't
both of them
matter.
are correct. Yeah, someone was asking, can you repeat?
Yeah, sir, sign will matter.
Yeah, sign do
Side.
matter. That's why in point biserial coefficient question, you will see we always ask the absolute value. We never ask the exact value because both are correct, right? If you take it as 0 or it as 1, it changes the answer.
Yeah.
मैं अगर एग्जाम में 0.37 लिख देता हूँ तो गलत होगा कि सही?
We always ask the absolute value for point
Okay.
biserial correlation coefficient. So sign don't matter. Okay, that's any doubt from the slides? Yes, Pranjal Kumar.
Yeah, I don't have a doubt from slide, but I have a doubt from practice assignment 3.1 of week
Okay,
3.
yeah, you can do that. Yes, someone also, I think Krishna was also saying from practice assignment. Things here.
Yes, sir. Can you go to practice assignment 3.1? In my this one fourth question.
It's 3.1 is different for everyone. You just have to tell me the question.
Okay, if the mean and standard deviation of observation x1, x2, x3 up to xn of 20 and 5.
Yeah, this question.
These type of questions, if you
yeah, we will cover such question in mock test also.
Okay, because this is this involves little bit of interlinking of the concepts.
Yeah, that's some conceptual question.
Yeah, means if you can have a separate additional questions consolidated with these type of approaches, it will help us actually.
Okay, we will try to cover it in the mock session. Mock session I will be taking. And
Mock
I will
session
also ask.
will be in the evening. Huh?
Yeah, both sessions are 7 to 9, mock session and revision session. A revision session Prashant will be taking. I will ask him also to take such questions. Okay?
Yeah.
Yes, Pranjal, what's your doubt?
And also you
There question in practice 3.1 that it was like that the 5 number summary of 99 observation of a numerical variable is 25, 35, 47, 56 and 78. Based on this information, which of the following statement could be true?
Okay, for that you can go through week 3 open session. We have discussed that question for like half an hour at least.
Okay, sir.
So values that are affected by outliers.
1 minute. Yes, Krishna, you were saying something.
Yeah. Also, if you can give some tips how to approach and solve these type of questions. That will be helpful.
These are just a general question. You just have to use the property of mean and standard.
Yeah.
If you know that it's affected by this or not.
Means what mean standard, if you have a comparison in one sheet, how it behaves, then that will be easy.
Okay, we will try to cover all the tricks and concepts.
Yeah, that will be helpful actually. It means interlinking between one and the other. Then it will be fast. Not only faster, we can also start relating nicely.
Yeah, everything is related because
yeah,
everything is linked. Yeah, you need to just catch that link pattern.
That is where little struggle is.
Okay, yeah, we will try to do that. We will try to structure session like that if possible. Okay. Yeah.
Because one thing is for central tendency, if we add or subtract, the new results will be addition and subtraction. Similarly, multiplication also same. Multiplication and division is same.
Yeah.
For outliners, there is nothing. Addition and subtraction doesn't have any effect. Only multiplication and division.
For variance thing, yeah.
For the outliners.
Not outliers.
Sorry, the
The
variance.
measure of
variance.
dispersion.
Dispersion, measure of dispersion.
Yeah.
So range.
Range is also a measure of
variance.
dispersion.
Yeah.
But
Variance and the standard deviation will have this effect. So if we try to combine these two, how to link? So then once we come to know, understand the link between these two, then we can easily solve this plus and multiplication, these type of questions.
okay. Yeah, if you know the formula, you can still do it, right? If I know the formula for, let's say, variance, right? Population variance.
Okay.
Okay, let's say I have added a constant A to each observation. Okay.
For variance, nothing will, no change.
Yeah, you can also check it, right? My new observation will become xi plus A, right? My mean gets added by A.
Okay.
You see that A gets cancelled out. So it don't get affected by adding. So if you know the formula, you can just try and generalize these things also.
Okay.
We will cover that in the revision session. Okay, outliers. Yeah. Who was asking this? Yeah.
So I'm asking.
Yeah, outliers. Okay. Let's say take this data set. Okay. 100. Okay. If I find mean of these values, it will be something around, I think, 5, 10, 17, 26, something around 5, right? Approximately. As you can see that 5 is also the middle of this data. Like if this is my data set, it balances it. It's the middle observation, right? But if I add this 100 to this data set, okay, so my mean will become something around 21. In that case, what happens is all my data is over here, 2, 3, 5, 7, 9. Then this central value and then this 100. So this don't balances it anymore. So mean gets this mean is not the central value anymore. So you can see that if I get any outlier value, my mean will be affected a lot, right? But it's not in the case of median, because if you calculate median for this data set, it's 5. If you calculate for this data, including 100, it still will be still 6, which is still the middle value.
Yeah.
Right? That's why median is not affected.
Mode.
Similarly, see, let's say this is my data set. 1, 2, 2, 2, 900, right? If you consider this data set, my mode is 2, right? It still balances the data.
Yes.
Even after adding outlier, my mode will still be the 2. Still not affected. Right?
And so variance, covariance, this will affect.
Yeah, because these all depend on the mean, so they will get affected.
Range will not affect.
Okay, range is what minimum minus range will also get affected. Range will also get affected. Just by plugging in the formula, just take some sample data set. Okay, here the range is 7, right? But if you add the outlier, the range becomes 98. So it is affected.
Okay, so apart from median and mode, other all values will get affected by outliers.
More or less, yeah.
Okay, thank you, sir.
Okay. Anyone anything else?
Sir, if row related frequency is say of similar trend, so
Yeah.
column related will always be of similar trend, or we should calculate that.
Yeah, it will always be of similar trend.
Okay. Okay. If that is similar, it will be similar. If that is different, it will also be different, right?
Yeah.
Okay. Okay. Thank you, sir.
Okay. Anyone anything else?
Excuse me, sir.
Yeah.
In coefficient correlation, if my value is 0.55, is it moderate or
Yeah,
it is?
point if it exceeds, it's in between 0.5 and 0.75, right? So it's moderate.
Okay, sir. Thank you.
Okay. Anyone, anything else? Or again? Okay, then I think we can close for today. Okay.
Thank you, sir. Thank you.
Yeah, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much, sir. Thank you
Thank you,
very
sir.
much.
Thank you everyone.
Thank you, sir. Thank you, sir.
Yeah, thank you. Thank you.
Thank you, sir.
Yeah, thank you.
Thank you.
You all can leave. We will close this session. Yeah.
Thank you, sir. Good night.
Yeah, thank you. Good night.